that topic, which is stoichiometry. Any questions, any problems, any issues, anything you want to discuss? No questions? Let me just give a brief rundown of things that you need to gain from that. It's quite a lot, I must admit. This particular chapter is quite heavy on the math, especially, all right? So I can appreciate if you find it a bit challenging, but basically a couple of things that you need to be aware of. Firstly, you need to be able to balance equations, right? I think I made that point at the very outset in the very first video on that chapter, right? You must have a balanced equation to work with. If the equation is not balanced, then more than likely every calculation that you do based on that will be incorrect, all right? So therefore, that's the reason why I gave you those assignments based on the previous chapter where you did a whole lot of balancing of equations, because that is a skill that you need to master in order to do stoichiometric type problems. In addition to that, you need to understand what the coefficients in the balanced equation represent, right? And it depends on what level of our discussion we're talking about when it comes to that. If you're talking about at the microscopic level, in other words, if you're talking about atoms, molecules, and so on, then those coefficients would represent the number of molecules if you're dealing with covalent compounds, or the number of formula units, all right? So if you're given an equation like 2H2 plus O2 to give 2H2O, what that equation is telling you is that for every 2 molecules of hydrogen reacting with 1 molecule of oxygen, then 2 molecules of water are produced, all right? So you can look at it in terms of the actual molecules. You can also look at it in terms of moles, all right? In other words, you can say, based on this, that 2 moles of hydrogen will react with 1 mole of oxygen to form 2 moles of water, which will become very important when you're doing calculations, right? Because once you establish these relationships, the mole relationships between different substances, then if you're given a certain amount of one substance, you can, based on the equation, calculate the number of moles of another substance involved in the chemical reaction, all right? For example, to choose one from the quiz, where you're given this equation first to balance. Of course, to balance this, we're going to need a 2 here, a 2 here, and a 3 here, in order to balance that equation. And the first question says, how many moles of ammonia will be produced if 2.5 moles of nitrogen reacted? So you're given 2.5 moles of nitrogen, and you're asked to determine the number of moles of ammonia. All right, so I like to start off by writing this down, right? I write down what is given and what the question is asking for. And then I start off with what is given here, and I ask myself, what will be the conversion factor I would use to convert from moles of nitrogen to moles of ammonia? So I go to the equation, and I look at the equation, the coefficients more specifically, and I see here that for every 1 mole of nitrogen that is reacting, 2 moles of ammonia will be produced. So I would represent that as a conversion factor, where I would put 1 mole of nitrogen below, so that this unit will cancel with this unit, and I would put 2 moles of ammonia above. All right? So the moles of nitrogen units will cancel out, and at the same time I'm introducing the moles of ammonia unit here, right? So your answer will be in moles of ammonia. All right? And you do your math, and this will give 5.0 moles. All right? So that's just a relatively simple example of that type of calculation. Of course, if you watch the other videos based on the same chapter, you'll see that calculations can become more complex, because you could be, for example, given, instead of given the number of moles of one substance, you could be given the mass of one substance, in which case what you'd have to do is convert the mass to moles, then you use the mole ratio to find the number of moles of the other substance, and then, depending on the question, if you're asked to find the mass of that other substance, then you go from moles to grams or kilograms or whatever, depending on the question. All right, so that's pretty much most of chapter 9. The latter part of chapter 9 deals with percent yield, theoretical yield, actual yield. I think I'm going to hold off on discussing that for now, because what I want to do is give you the assignment based on what I've just talked about. I think, let me see if there's anything I need to talk about apart from that. Because I remember I went through some examples, and let me see. Yeah, I think I've basically covered everything up to limiting reactants and percent yield. So, let me give you this assignment here. And of course, if you have any questions, please feel free to ask. If there are any extras, you can just pass them up.
My paper here, I was marked 2 and 4, and in his it's the same thing, and he was marked 4 and 4.
Yeah, but that's because you didn't balance it. I put a 2 here.
Oh, all right.
You were right about here and here.
Oh, yeah, I thought that was my 2, that's
No,
my
no.
fault.
Mhm.
Kind of my fault.
All right. Question? Yes, sir.
For these, are we assuming that we have unlimited amount of data?
Yeah. Right. Because we're not dealing with that situation yet. Mhm.
trying to write down,
Mm-hmm.
but it's like moles is correct.
Right, so what you have to do, as I said before, you have to convert the 200 grams to moles. Now, you remember doing that from the previous chapter? If you're given the mass of one substance in grams, how would you convert it to moles? How would you convert 200 grams of sodium hydroxide to moles? Anybody can answer that question?
1 mole over the molar mass.
1 mole of sodium hydroxide over the molar mass. How do you get the molar mass? You add up all the molar masses of all the elements that you get from the periodic table, right? So you add up sodium, which is 22.99, plus oxygen, which is 16.00, plus hydrogen, which is 1.08, and if I'm not mistaken, that's about 40, right? Or
40.9.
I'm sorry?
40.07.
40.07?
I got 39.
Yeah, I got 39.99.
Yeah, I think that is more likely correct. 39.99
Yeah.
grams of sodium hydroxide. So does that answer your question? So you know what to do next, right?
Set it up like that.
Exactly, exactly. And make sure you calculate the molar masses correctly. That, those are some little errors that students tend to make. They add up incorrectly the molar masses. Is Gillette here? Long, Main, Smart, Stroud, Question? Yes, sir. No, because what you have to recognize is that the sulfur is heavier than okay. Okay, are you sure this is right? Oh, it should be 2 times 22.9. And 4 ounces, right. Yes, boss, please be careful when calculating the molar masses. Please, yes, ma'am. Okay, that's right. Okay, that's right. Assuming that this is correct. That's right, so, looks right. All right. All right. Yeah, from 3 to 7. Yeah. I think, hold on, let me check to make sure. Actually, 2 to 7, not 3 to 7, 2 to 7, yeah. No, tomorrow I won't have any office hours. I can, if you want to, I can make a special appointment. Which day of the weekend do you think you'll be free? Or, all weekend? All right, tell you what, let me get back to you on that. I'll send you an email. All right?
Number one.
All right. This is what they're working on right now.
You're missing the
Yes, ma'am. Okay, this is our okay. Assuming that this is yeah, that's right. Now remember, yes, sir.
This in here is the middle of the burden. Need perfume, but also this. This.
Okay. One error you made here is that you should have one thing here. You know why?
This for one level of that. So you sort of divide
See that?
that?
Right. So you need to make sure that this represents the right conversion factor.
So really, so this is all that.
Yeah, so this part is wrong, which means that when I like this is wrong. Another thing I would recommend too is that you do everything in series. In other words, you go through, you put this conversion factor and then put this right next to it.
Oh.
Right? Because each time you round off, you're introducing rounding off first and you do it piecemeal like that. You see what I'm saying? So,
Now, but I did it on a separate sheet of paper.
you can get a little, yeah. Yes, sir.
I think I did it a little kind of differently than, but I got the same answer, so we should do it. I guess more directed.
Okay.
I just converted the whole concept.
All right, so you're saying 0.5 moles, okay, that, okay, I strongly suspect that this is not correct, however, because based on what I've seen, in fact, I think you have the right value here. This should be here. Oh, I see what you're saying, okay.
Because that's, I told them all that, per that.
But if that's the case, you don't need to multiply by 2 then. You can do it this way, which is kind of weird, but nothing wrong with it.
Yeah.
But if you're doing it this way, you don't need to multiply by 2 here. Because you have already taken care of the ratios here, the mole ratios here, and here you basically divide the molar mass by 2, but you took care of that by putting 0.5 here. So that's fine. So the only thing that is wrong here is this 2 right here.
Because once I got going, I could have changed it.
Right, I understand, yeah. Question?
Yeah.
Come on. Yes, sir. Okay, so first thing you need to do is find the number of moles, which is what I was explaining over there. Take the 200 divided by the molar mass, 1 mole of sodium hydroxide. Now remember, the aim of this exercise is that you're going to start off with 200 grams of sodium hydroxide,
I got like 4.
and you're trying to find the number of grams of sodium sulfate. All right? So what you need to do first is go from grams of sodium hydroxide to moles of sodium hydroxide,
Wait, why is this a 31?
which is what that was about.
39.
Right? And then you have to go from moles of sodium hydroxide to moles of sodium sulfate. And that's where the mole ratio arising from the coefficients that one over here, right? So we're going to use that relationship to go from here to here. And then the last step is where you go from moles of sodium sulfate to grams of sodium sulfate. All right? And in that case, you're going to use the molar mass of sodium sulfate. In other words, you'd have to look up the molar masses of all the elements that make up sodium sulfate from the periodic table, add them up, and you're going to multiply the moles by that number to get the grams of sodium sulfate. So basically, you're going to use 3 conversion factors in series. So first step, going from here to here,
Why there's only one
we're going to
mole?
put 39.9 grams of sodium hydroxide by adding up the molar masses of sodium, oxygen, and hydrogen.
Be 32 for
You know
row.
what I'm
I
saying?
need a atomic number.
So the next step, what do you think is going to be the next conversion factor?
Now you know.
What, yeah, but what goes here, what goes down here? Moles of what? Sodium hydroxide, right? And moles of what will go up here?
That would be.
Exactly, sodium sulfate. What would be the number? That's the next thing you need to figure out. What would go here and here? The hint would be from here. Right, so what number would go here? Exactly, 2 here, 1 here. And then the next step, which is the final step, is where you go from, because notice, that's going to cancel, that's going to cancel. So the only unit remaining here would be moles of sodium sulfate. You need to go from moles of sodium sulfate to grams of sodium sulfate. So what would go down here? What do you think is going to go down here? Yeah, but one number, moles of sodium sulfate. One number. 1 mole, exactly. And what would go up top here? No? The molar mass. You'd have to add up. Right, so you go to the periodic table and add up all the molar masses of sodium, sulfur, and oxygen. And don't forget, because I noticed some students making the error, you need to multiply the molar mass of sodium by 2, where sulfur will be 1, and for oxygen, you multiply by 4 to get, and add them up to get that number up top here. All right? And that's it. Once you work it out, that would be the answer. All right? Yes, sir.
Like that?
What is this here?
Oh, I just did that.
Oh, right, well, you didn't need to do it. Just that equals that, and that's it. Yeah, so that's what you do. Yeah. Yes, ma'am. Okay, so 255 grams of lithium sulfate. How many grams of lithium nitrate? Okay, so the equation is this. So, okay. You're going to use this, but you have to do something first. You have to convert the grams of lithium sulfate first to moles, just like you did here, right? So you're going to use this, don't, you know.
That's
this
right, the next step.
Exactly. Yes, sir. Okay, so, assuming that is correct. And then lithium nitrate, okay, I think you have, 42, 2 to 1, okay. So it's, and then 68.5. All right, that looks right. The only thing I would say is, just to make sure everything is straight, to make sure you put like here, lithium sulfate here, and lithium nitrate here. Yeah.
But what I was going to say is 322, that doesn't just, it doesn't seem to make sense because this is 28. You need more of this than this.
No, well, it's kind of hard to see whether or not it will make sense. The only way you can see it is if
I just remember it was like the original chemistry, look at your answer.
right, exactly. That's what I'm saying.
Yeah.
You're thinking more along the lines of conservation of mass. You see, the only way you can make sense out of it is if you,
What you can tell them.
Right, but what you have to understand is that there's another product here. I remember it reacted, there's another product here. And remember the lithium nitrate also reacted with this. And we're assuming that we have enough of that. Right. So as long as the numbers work out, as long as especially the molar masses are correct, you don't have to worry about anything. Yes, ma'am.
I just want to make sure that all the conversion factors
Okay.
right. On the second one,
More moles of right.
Okay.
Okay, again, assuming that these
Because
correct.
I read about in the video, I saw it's the desired amount of,
Right,
but in
exactly.
this one, we're going like that.
Yeah, but it's still the same principle,
Okay.
because what is the desired amount would be
Right,
what the
that's
question is
right.
asking for.
Okay,
Right, so, yeah,
okay.
which is grams of lithium nitrate. That's what you're working towards. Yes, ma'am. Okay, if 120 grams of, okay, so basically, they gave you 120 grams of sodium carbonate, and they're asking for how many grams of sodium hydroxide, right? So this is what you're given, this is what the question is asking. So just as you did in the previous example, you have to convert the grams of sodium carbonate to moles. So how would you do that? 1 mole of sodium carbonate above, yeah. And the mole of, oh, you calculated already?
Sure, which one are you?
Oh, okay, I didn't see. 105.99 grams of Na2CO3, correct, okay. So that this will go with that. What do you think? Oh, back up. Remember I said that the most important thing is to make sure that the equation is balanced? It wasn't balanced. Look at this here. You got 2 sodiums here, 1 sodium here. So you have to ensure that the equation is balanced. And I think it is now balanced, right? Right, okay, good. So, what do you think the next conversion factor is? Okay, so what goes up top and what goes below? Okay, so 1 mole of Na2CO3 below, and what goes up top? Two moles of NaOH, exactly. And then what?
And you times it from grams to moles.
Okay, so what goes up top, what goes down here?
1 mole NaOH at the bottom,
1 mole NaOH below,
and
Well, it's always good to double check though.
8 grams.
39.9,
Not all these are.
8 grams.
Okay, and then
NaOH.
the more weight of carbon is 12.
And that's it. It's very similar to the other two.
Because it just threw me off.
It's just the way it's worded.
Yeah.
But it,
That's what threw me
exactly,
off.
right. But it basically gives you something to start off with, and it's asking you how much of another substance.
Okay.
Same thing. Yes, sir.
More weight
That's
of
very good.
1.09.
Convert the moles. Okay. Okay. You're right about this part here. Okay. Where you slipped up is that you assumed that the moles of lithium sulfate is the same as the moles of lithium nitrate, which is not so. Because of what you have to look at are the coefficients here. You have 2 here, you have 4 here. So what that tells you is that whatever the number of moles of lithium sulfate that is produced, the number of moles of lithium nitrate that reacted with it will be twice that amount, because there's a 40 mole ratio. Ultimately, yes. Ultimately.
So, I just changed it because of the coefficients.
Yeah, but what I want you to do, if you're going to do it this way, I want you to show the units. For example, the units here would be grams. The units here would be grams per mole. Another thing I suspect, I don't know for sure, but I suspect that you may have, okay, here's another area you made, I just realized. You multiply 4 times 6.94, right? You don't do that to get the molar mass. When you're calculating the molar mass, you simply, if you're calculating the molar mass of lithium sulfate, you go just based on the formula. The coefficient is not used to calculate the molar mass. So it should be 2 times, what is it, 6.94 plus 32.06 plus 64, and that's how you do that. All right? All right.
We want to get everything together. Now we can work from one. This is going to be great. But when it's completely unnecessary, just put it in the shower. Okay, so we have 1 mole on the bottom of calcium oxide. On the top we have 1 mole of calcium carbonate. Yep. So we need to convert calcium carbonate to one mole.
Oh, by the way, you were the one who had that problem with the videos last week. So what I suggested worked?
Yes, I
Okay, all
had
right.
that before, I would always have to hit show all contact, but for some reason,
Uh-huh.
it wouldn't work until I changed the whole setting.
Uh-huh.
And I still have
Well,
to
actually,
show
I had
for
this
every
for
video.
5.
Right, exactly, that's what, right.
So, I don't know what
The lady I spoke to at the Ocala campus, at the Angel Help Desk, she said that it's a result of a new version of I use Firefox. So it's a kind of security feature that they've
And I use Internet Explorer.
right, she didn't say that for Explorer, but she did say for Firefox. It's a new security feature where if you're going to open up a website which has certain security things in it, you have to give your browser the permission to, and you have to do that, and for every video you have to do that, right, exactly.
Everyone.
Yeah.
Oh, that's this thing.
Having fun?
Oh, wait, no, I have one. Okay. No. Oh, yeah. So the volume is the mole of calcium carbonate. More math, 100.09. 100, yeah, 100.09. Right. Okay, now we just multiply across the top. If you see something on the bottom, something on the top, multiply that. And around pretty significant here, so we should be 89.2 grams calcium carbonate. Is that what you got? Does that help you understand it? No, that's just, this one, how that's 8. Oh, this is, oh, but it's automatically substrate. And with phosphorus is 4. That's like that. What is the, in front of the copper? No. The first term is Cu. It's positive. Yeah, you're right.
Finished? Thank you, sir. And take this. Oh, this one. I'm gonna head it here somewhere. Before you leave, folks, make sure that you take up one of these. So we'll do next week, all right?
Do we have to figure by Friday? That one?
No, next week. That will be due next week. This one, if you're not finished with it now, will be due on Friday. What's the name of it? Well, it increases over like 5% of the total, so it won't hurt you. Let's see what this is. Oh, so it'll be 4.
You want some?
Yeah, that's what can work. All right.
You know, but Alan.
Sure.
I'm gonna get to it.
So you have 5 moles of oxygen.
So you're saying.
Okay.
So you got a down.
Yes, yes. So if you, oxygen, you actually but then you have 5 moles of oxygen, and you convert it to moles of mercury oxide. So you have 1 mole. Oxygen compared to 2 moles of mercury oxide. Mercury 2 oxide. And then you multiply. That's it. So what's how many moles of that? So you don't even need calculator, it's just runs mix of beers and 1 0 moles.
Yeah, I'm gonna look at that later on. You know what I'm saying? So they're the same until like.
Actually, there are a few other ones where it only has one that requires an octo. So those are the two steps. What? Oh, like here. Except for that one is actually. That's 50.0 grams. That's a G.
Somebody on the floor right now.
That's a G.
It's hard to come up with reading upside down.
I don't exactly have this handwriting. Yeah, see what they do is, you know, each bubble, there are more mass. First thing I do. Well, you see, it gives you 2 substances, like you got the mass, it gives you the mass of 1 substance. You got the mass of the other.
Let's go.
It does more mass of those 2 substances. It does more mass of those 2 substances. Like here, let me show you. Okay, this one, lithium, nitrate. This one, which is how much you need. And you have lithium sulfate. It's got more mass of these 2. So then you they give you like this one. Yeah, so that's all 4.
Right now.
you divide this by the more mass, then you convert moles, and then multiply by the more mass. You need to have the more mass before you even begin. It's the first thing you do.
That's why I changed my major.
After balance.
Well, I'm not trying to do like physics there.
Using like an assistant.
No. They,
So you know the first step. Together. Dividing by the more mass of the substance, right?
Thank you.
So that's
So, the first thing you do
much
is
the same
figure out the
process
more
until
mass.
like here.
Yeah. You figure out the more mass.
Two different
This one for electrons.
Which is fine.
Oh, you
I
do
think
not
that's
factor in
math.
coefficients.
Math, I don't have a problem.
Really?
Oh, yeah, that's not factor in.
They'll call that-
So, yes, that's the two here.
That's the reason why.
I think I did this one is marking up the red dash.
That works.
Okay, 576.
I already had, number 5, I think, you can have it back. I just finished
Okay,
it.
I'm curious,
I
why?
put it on my phone.
I just need to figure out how to turn it.
Oh, okay,
Is it down?
that's what it's okay, right, I just, okay. All right, yeah, that can work.
I mean, that's just how,
Yeah,
because I see it as like one more, like,
yeah, I understand, yeah. Makes sense.
Yeah, I'm still trying to figure out how to.
So then which one?
Okay, you're on your conversion number 2. Okay, you have 4 moles of this, right? That's what you're starting with? So you convert it to, so you put that on the bottom. Oh, that's 1 mole. Oh, if you convert anything to moles, you convert it to 1 mole. Of this.
Number 5, 157.
You put 4 moles of that on the bottom. No, wait, you put that on 4 moles on top. So now, put 2 moles of that on the bottom. Yeah.
I got me here. Did you need?
Okay, you know how you put that on the bottom and cancel it out? Yeah, so you're trying to cancel out the moles of lithium sulfate. So that'd be grams. No, that'd be moles, that'd be moles, right? 1 mole. No, it'd be grams, because you have moles up on top. So what you see, here's one thing like this, you cancel this out. And so you need to cancel this out, you need it for the product. You need to be in line and all 3. You're not working with this anymore. Yeah, 1 more on the bottom. 50 more off the top. 60s. L-I-N-3.
Thank you, sir. Don't forget to pick up a copy of the assignment 18, which will be due next week.
Can we submit this one on the Dropbox?
Yeah,